So for loading, it is not very difficult. You already know how to load the packages. We just use the library command. So library tidyverse, then library. I prefer to load them one by one. We are ready for the analysis, actually preparing the data. So let us try to get our data set ready. Data set ready. So I'm actually using several number of hashes to make it a title. So for getting the data set ready, what we will do, because in our data, as you can see, we have several columns. We don't need all the columns. Our intention is to keep only the date and the close P, that means closing price. We don't need the trading code. We don't need the yesterday closing price. Okay. So for doing that, we have to remember the column name, the variable name or column name, DATE all cap, and close P all cap. Okay, we have to remember that. We need to know that. So let us create a new data frame with only these two columns. Create and name a new data set only with date and close P columns. So for doing that, we can use a new name. So let us choose a name something like GPP, indicating price, only price. Okay, so previously we had all the data. Now we will only include date and price, closing price. So it will be created by at first loading the original data frame, that is GPD. Okay, so it has several columns. Now we will use a pipe operator. So this pipe operator actually passes the data frame to the next function. So what will be the next function? The next function is select. So select, and under select our argument will be, we will choose only date and close P. So now the select function will select only the date and close P columns from the data frame, from the GPD data frame, okay, excluding all others. So this is what the function will do. So let us execute this one. So we have got another data frame, GPP. So if we click this one, then we can see we have only date and close P. Okay, so far so good. You can always check the structure and all this thing again using the str or head command. Okay, you can always do that, but it is not necessary for me to do it now, because I can already see that we have date and close P, and we also know from previous code that our date is saved as character. Okay, and because we have not done any manipulation, so we can be sure that it is still character. So now what we have to do, we have to change the character into date. Okay, so we will convert the non-date format, that is character of the date column, into a proper date format using LubriDate actually. Okay, so convert the non-date formatted date column into date format. So how to do that? So for doing that, actually we will ask R to change the date column. Okay, so and assign and actually assign it to the same column. That means what it will do, it will just simply change it. So let us type gpp because we are working on this data frame, and in this data frame we ask to select only the date column. So the date column is selected and it will be changed after doing some manipulations. So what is the manipulation? Okay, what is the manipulation? It is actually mdy. So I will ask the database, I will ask the R actually by using the lubridate package, okay, to convert it into mdy format, because our character is like this. You see, the first part is month, the second part is day, and the last part is year. Okay, this is why we are asking to read the character as a character in this format and then convert it into a date. Okay, so mdy function. So which column should be executed, should the function be executed on which column? It is gpp dollar date. Okay, so what it is going to do, it is going to use the mdy function from the lubridate package to parse the date column. Okay, and mdy assumes that the data format is in month, day, year, which is true in our case. Okay, and then converts them into a standard date object. And after we execute, then what will happen? The converted date object will replace the original date column, and it will ensure that it is properly recognized as date for further analysis. So let us press Ctrl Enter. Okay, now we can check if it is okay or not. How can we check? We can actually run okay, it is actually another database. So let me copy this one and just change the data frame name. So we don't need the head anymore. Here only str is sufficient, str gpp. If we execute, then you can see date is recognized as date. Okay, and close free is number. That's not a problem at all. So this is how we can get our data ready. So here we have done two things. One is selecting only the needed columns and assigning it a name, separate name, and then converting a non-date characters into date. Now how to calculate return? Calculating returns. Okay, for calculating returns, we will use we will not calculate the percentage return, rather we will calculate the log return. Okay, log returns are preferred over the percentage returns because they are time additive. That means the returns over multiple periods can be summed. In case of percentage return, you cannot sum it directly. Okay, and also it will help to simplify further analysis, and log returns are also better to approximate the continuous compounding. So it is more suitable for statistical analysis and comparisons across different stocks with varying price scales or volatility levels. So this is why we use the log returns in case of stock market. So for calculating the log return, actually we will have a little bit longer chunk of code. So let me write calculating log returns. So it will be actually we will also assign it a new name and create new data frame with it. So the name of the data frame will be GPLR, indicating GP log return. Okay, so GP log return will be a data frame containing the stock price data, including the date, closing price, and all this thing. And one column will be added with a new variable called log return. Okay, so this will be the GPLR. So it will be developed from GPP. Okay, so we will ask to work with the GPP data frame that we have just modified, and then use the pipe operator. Okay, and then we will ask it to use the muted function. So what does the muted function do? Muted function creates new columns that are functions of existing variables. Okay, so under muted, I'm going to the next line to look it better. We will have new column called log ret, indicating it is a log return. How to get that? That there is a calculation for getting that. Okay, so we need to take the log of today's price, and we have to get the log of yesterday's price. So from today's log price, we will deduct yesterday's log price. Okay, so at first we have to log, then our today's price is in the close P column. Make sure that you use the capitalization properly. Close P minus log close P, and essentially the result will be 0, because we really don't want to deduct today's close P log from today's close P log. Rather, we want to deduct yesterday's close P from today's close P. Okay, so we have to use another function called lag. So lag will actually take the close P of one period earlier and take the log of that. Okay, so this will be the function. So what the components of this function are doing, log close P is taking the natural logarithm of each closing price, and lag close P actually shifting the closing price column down by one row to align each price with its previous period. Actually, there is a mistake here. It will be log, and this one will be lag, because we have to take the log of the lagged close price. That means previous day. So let me tell you again. At first, the lag of the today's close price, that means lag means one period earlier close price, that will be taken, and then log of it will be taken to deduct from the log of today's close price. Anyway, so if we execute, Control Enter, then we get another data frame GPLR. Okay, GPLR. So this will give us the file with the log return. Okay, this column is actually showing us the log return.